Dear students, in this lecture we will be discussing on different types of single-phase induction motors. In the previous lecture, when we are discussing on plain single-phase induction motor, I had already mentioned that single-phase induction motors are inherently not self-starting. By explaining double revolving field theory, we had seen whenever a single phase supply is provided, there will be a sinusoidal or pulsating flux that is produced, and we can resolve the sinusoidally varying flux into two components with same magnitude, that is 5m divided by 2, and will be rotating in opposite directions with synchronous speed. And because of the same, there will be two torques that are produced and will be opposite in direction, and because of the same, at standstill condition it will not be able to start. There will not be any resultant torque. But if we are giving a push on the rotor to any one of the directions, that is either in clockwise direction or in anti-clockwise direction, the machine will continue to rotate and there will be a resultant torque and the motor will pick up the speed. So one of the main disadvantages in the case of single phase induction motors is it is not self-starting. So it is to be made a self-starting one. There are several methods that are used for making single phase induction motor a self-starting one. The stator winding will be divided into two, or it will be split into two parts and will be displaced in space, and by which the machine will be almost similar to a two-phase machine for the starting, and on running condition it can be made as single phase. Different single phase induction motors based on this starting arrangement are split phase resistance start induction motor, capacitor start induction motor, capacitor start capacitor run induction motor, shaded pole induction motor, and permanent split capacitor induction motor. We will see the types of induction motor one by one. The first one is split phase resistance start induction motor, and the cross-sectional view of the machine is shown in the figure, and the winding connections are also shown. We can see there are two windings on the stator side, that is main winding and auxiliary winding, and the speciality of these windings are, for the main winding the resistance will be less and the reactance will be more, and for the auxiliary winding the resistance is more and the reactance is less, and the auxiliary winding is connected in parallel with the main winding but through a centrifugal switch that is given in the figure as SW. The rotor side is same as that of the ordinary plain single phase induction motor, that is the cage type of rotor. The windings, that is auxiliary and main winding on the stator side, will be displaced by 90 degree in space. Here the phasor diagram is also given. V is the applied voltage and Im is the main winding current, Ia is the auxiliary winding current. Since the reactance is more for the main winding, the lagging angle will be more for Im with respect to V, and since the resistance is more in the case of auxiliary winding, the angle of lag will be less in the case of auxiliary winding current Ia. Here we can see there are two currents on the stator side, that is auxiliary winding current and main winding current, and they are not in phase but they are displaced by an angle alpha, and we can find the torque developed will be proportional to sine alpha. Since there is an angle difference, it can be considered to be almost same as that of two-phase system. And when the machine picks up speed, the centrifugal switch will be opening up and auxiliary winding will be removed from the, or it will be cut off from the circuit. Only main winding will be there for running condition. The characteristic features are given and we can find the starting torque is 1.5 to 2 times that of the full load torque, and the power factor is less, that is only 0.6 lagging, and the efficiency is less, only of the order of 60%. Good speed regulation is possible and the reversal of direction is possible in this type of machine, and the torque speed characteristics also is given. Here we can find if only main winding is there, that is M winding, the starting torque will be 0, but with main winding and auxiliary winding, the starting torque is around 1.5 times that of the full load torque, and in between there is a switching that is shown, that is at around 75% of the speed the centrifugal switch will be opening up and only the main winding will be there in the circuit. Few applications are given for this type of machine, that is for washing machine, food mixers, grinders, floor polishers, blowers, centrifugal pumps, drills, lathes, machine tools, etc. The second type of single phase induction motor is capacitor start induction motor. Here again there are two windings on the stator side, that is main winding and the auxiliary winding. Along with the auxiliary winding, there is a starting capacitor included in series with the winding and a centrifugal switch given as SW. As in the previous case, the machine will be starting as two-phase machine, and we can see since there is an additional capacitor that is included along with the auxiliary winding, the current in the auxiliary winding will be leading by some angle. Because of that, the angle between the auxiliary winding current and the main winding current can be made closer to 90 degree, and this will be helping to increase the starting torque, because the torque is proportional to sine alpha. Here alpha can be made almost equal to 90 degree, and when the machine picks up the speed around 75%, the centrifugal switch will be opening up and the machine will be running as a single phase motor. Here we have the characteristic features that are given. We can find the starting torque is much improved in capacitor start induction motor compared to the split phase resistance start induction motor, that is 3 to 4.5 times that of the full load torque, and the power factor is also slightly improved, that is 0.65 lag. The efficiency is also improved to 65%, and the reversal of direction is possible in this type of motor too, and the torque speed characteristics also is given, and the few applications are: it is used for loads of higher inertia where frequent start and stop are required, and for pumps, compressors, large washing machines, conveyors, machine tools, etc. the capacitor start induction motors can be used. The third type of single phase induction motor is capacitor start, capacitor run induction motor. Here we have two capacitors that are used, that is along with the auxiliary winding there is a parallel combination of two capacitors, that is a running capacitor and a starting capacitor, CS and CR. That is CS is a starting capacitor connected in series with a centrifugal switch, and CR is a running capacitor which will be always there in the circuit. So at the beginning, the combination of the capacitors connected in parallel will be there in the circuit, and which can help to increase the starting torque by improving the power factor of the machine or of the winding, auxiliary winding. And on running, CR will be remaining in the circuit along with the auxiliary winding. In the previous two cases, the auxiliary winding was cut off from the circuit for running condition, but here both the windings, that is auxiliary winding and main winding, will be there in the circuit for running too. Here also the angle alpha, that is the angle between the auxiliary winding current and the main winding current, can be made almost equal to 90 degree by proper selection of the running and starting capacitors. The characteristic features are given. We can find the starting torque is improved and the power factor is also improved and the efficiency is high. The direction change, that is reversing of the direction, is possible in this type of machine too. And the torque speed characteristic also is given. Here we can find for running it is having a better performance compared to the previous two cases because the auxiliary winding along with the capacitor is included for running too. And few applications are also given, which includes conveyors, reciprocating pumps, compressors, fire strokers, etc. And the machine can be used for the applications where we require higher starting torque. Another type of single phase induction motor is shaded pole induction motor. Here the stator is of salient pole type. That is, there are projected poles on the stator side on which the corresponding winding, that is stator winding, will be provided. And there will be a slot cut on the projection of the pole. It will be cut at a portion 1/3 of the total portion, and the smaller portion will be provided with a ring made of copper. That area is called shaded region or shaded portion, and the ring is called shading coil. And this slot will be provided on opposite sides of the poles. The rotor is same as that of the previous cases, that is only the cage type of rotor. Because of the slot that is made and by providing the shading coil, the air gap flux that is produced in the case of shaded pole induction motor will be a non-uniform one. When we consider the positive cycle of flux wave, we can find the MNA, that is magnetic neutral axis, will be shifting from left to right as shown in the figure, and for negative cycle also the MNA will be shifting from left to right. That means there will be a sweep for flux in the air gap, a sweep from unshaded portion to the shaded portion. The sweep of MNA or the shift in MNA is shown in the figure with respect to the waveform that is given, and we can find when we compare the time T1, T2, T3, the MNA shifts from left to right, that is from unshaded region to the shaded region. The sweeping of flux can be compared with the rotating magnetic field, and we know whenever there is a sweeping of this flux, correspondingly the rotor will be trying to rotate in the same direction as that of the sweeping of the flux. That is how the shaded pole induction motor will be operating. The characteristic features are given. The starting torque is less in this case. The power factor is also very low. The efficiency is very much less. And here, compared to the previous three cases, the direction change is not possible in this case. The direction of rotation will be from the unshaded region to the shaded region only. Torque speed characteristic also is given in the figure. When we consider the application of shaded pole induction motor, it can be used for the applications where we require a low starting torque. For example, table fans, exhaust fans, hair dryers, cooling fans, record players, slide projectors, photocopying machines, timing motors, etc. So in this lecture we are discussing the starting methods that are used for single phase induction motor, and we have discussed different types of single phase induction motors and their characteristics, applications, etc. Hope you have understood. Thank you.